Hello and welcome to Lockdown Mathematics. Today we're going to be dealing with the second part of some basic trigonometry equations and trig graphs. Okay, so let's get right into it. Okay, the first thing we're going to discuss today is the compound angles and double angles formulae. Okay. So the best way to remember this problem is going to start like this. So let's look at this formula, cos of A minus B. In cos of A minus B, we always have cos twice with two different angles A and B, and sine twice with two different angles A and B. But because we have a C in cos, you can remember the C in change. Now what you'll do is, where you got a minus sign, you'll substitute a positive. Okay, similarly for cos of A plus B, the positive will become a negative and you'll have cos sine. Now let's look at the case where we have a sine. In the case of a sine where you got sine of A minus B, think of S in sine and S in same. We're going to keep the sign the same, but the only difference here is you don't have two of the same trig ratios first and second. So here you got sine of A, then cos of B, keeping the sign the same, you got cos of A, sine of B. So in the similarly, sine of A plus B is sine A cos B plus cos A sine B. Okay, the next thing we're going to look at are double angles. Double angles, as the name suggests, is 2 times that angle. So sine of 2 theta becomes 2 sine theta cos theta. And cos of 2 theta is cos squared theta minus sine squared theta. So it's like the square identity, but there's a minus sign between them. Right. We can then rearrange cos 2 theta using the square identity. And if you substitute the square identity into this equation, you will get 2 cos squared theta minus 1, or you can get 1 minus 2 sine squared theta. Okay, moving on to the next section, we're going to be dealing with trig graphs. Okay, so the first graph we're going to be talking about is the sine graph. So what you need to know about the sine graph is that it has a shape like an S. Right, so you can see that here in the top left. Right, what's characteristic of this is you need to know that a sine graph intercepts at positive and negative 180, at 0, and positive and negative 360. Right, so here's 0, it intercepts here at 180, and then it intercepts here at 360. Right. Its amplitude is how high it is, between 1 and minus 1. And the domain or period is between minus 360 to 360. Right? The turning points, which can be seen here and here, is at 90 and 270. And so I'm going to show you how easy this is and how it will help you for the next graph. So the next graph is a cos graph. Right? Notice that the sine graph starts at the origin. So basically the cos graph is shifted by 90 degrees. It's basically the sine graph shifted by 90 degrees. So I'm going to take this whole graph and move it 90 degrees to the right. And so if I look down here, what you should notice for a cos graph is it doesn't start at 0, it starts at 1, and it makes a characteristic C shape, characteristic cup shape, and in a cup you have a C, right? It intercepts at 90 and 270, so notice that whatever was the intercept and turning point for the sine graph swapped for the intercept and turning points of the cos graph. So if you know that, you're just going to quickly swap the two sets of values. The amplitude remains the same, which is 1 and minus 1, and the period as well. Okay, so I hope this was of good help to you. I'll be doing some trigonometric examples for exams, and I'll be uploading them as soon as possible. So stay safe, guys, and hope you have a good day.